We have understood the amount of buoyancy force, but location of force is very important. So where this buoyancy force acts right now, that we call center of buoyancy. Center of buoyancy. And what is the center of buoyancy? Try to understand. It is the centroid. Again, I am writing in a bold letter. Centroid of or geometric center of the volume of fluid displaced. So it is the centroid of volume of the fluid displaced. For an example, in this our case, it is fully submerged in a water. So center of buoyancy will be at the center of gravity. Center of gravity and center of buoyancy will coincide. But try to understand this concept. So you have like this. You have suppose you have like this, or you can say you have a sphere. So half of a sphere is inside the water. This is the water level. So you have to find, this is the volume displaced, and this is the, so we have to find center of a geometric center or centroid of this part. So you have to locate. This is the center of buoyancy. So basically, the center of buoyancy is a centroid or geometric center. But it is fully submerged in water, then center of gravity and center of buoyancy both will be at same place, and both will be on the body, right? So in a submerged case, center of gravity and centroid geometric center, that is your center of buoyancy, will coincide. But when it is partially submerged or it is floating, center of buoyancy will be always below the center of gravity, because in this case it is center of gravity and here it is center of buoyancy. So center of buoyancy is always below the center of gravity in case of floating object. I think I have made clear. I have made things clear, right? So let us start. Let me check your concept. Let me check your concept. So you have an object on your body, and this is your 40%. 40% is your, suppose some what you call 40% and 60%, right? So 40% volume. 40% volume. It is fully submerged in a. No, this is not the problem. I will, let me check another very good problem. So we have understood the concept of buoyancy force and center of buoyancy, but you need to solve a problem to clear your concept. So problem 1, what is the problem? Find the density of metallic body which floats at the interface of mercury of specific gravity 13.6, that is 13.6 times heavier than water, and water such that 40% of its volume is submerged in mercury and 60% in water. Okay, please solve this. So you have an object and it is 40% of volume is submerged in a mercury. So mercury is heavier, so this is your mercury part. So this is your interface of, this is your water and this is your mercury, right? And this is your mercury and this is your water. It is fully submerged. 40% part is in a mercury and 60% part is in a water. So this is your mercury 40% by volume and this is your 60% by volume. So 60% in the water. You have to find density of metallic body. So you have to find the density of metallic body is equal to what? Please solve this. I give you 2 minutes. First to attempt. You guys are trying. Just no. Is horizontal force to be not be same if there is a fluid of different density on both sides? Yeah, yes, Anupam. If density is different both side, then horizontal force will be different. Sure, because horizontal force it is on a curved surface, so you know how to calculate the force on a curved surface. Already we have discussed in a fluid statics where force exerted by the fluid on a horizontal plane, vertical plane, and curved plate. We have already discussed. So we know how to estimate the force. So if cylinder is there and you have different fluid, this is your. So it is in a case of different fluid. See, it is a case of different fluid. So here force will be F1. If here force here one fluid is there water, this side fluid is there mercury, of course this force F will be different and this is your F1 and F2. So F1 will not be equal to F2, F2 will be greater than F1. Yeah, good question. So you know force will be yeah, let us solve this now. If you got this answer, then it's fine. 6040. This is your answer. Here weight will act, here buoyancy will act. So force of buoyancy will be equal to weight of the body. It is simple concept because it is in equilibrium, right? It is not moving upward or downward. So force of buoyancy is equal to weight of the fluid, and weight of the body is your rho density and then volume. and then you have a G. So this is the G. So this is the volume, right now, volume B, and this 60% volume is 60% V, and this 40% is 40% V. V is the volume of object, volume of body, that is V, right? So this is the weight, and that is equal to, this is your weight, and this is equal buoyancy force. So buoyancy force will be your buoyancy force due to water plus buoyancy force due to mercury, Hg, right? No, so because it is submerged, right? No part of the body is outside the fluid. So this rho Vg is equal to buoyancy force. How much water is displaced? So 60% water is displaced. So 60% volume, and then rho W into G plus this buoyancy force, right? And again this buoyancy force, right now, this will be due to mercury and water, and both the direction of buoyancy force of due to this water and mercury will be in a upward direction. That's why we have added it. And buoyancy force due to mercury, so 0.4 V, and rho W, so rho Hg and G. Here I have written water, here I have written mercury. So you can calculate now rho. So VV will be cancelled, VV will be cancelled, VV will be cancelled. So you can calculate now rho. GG also cancelled. So rho will be your 0.6 into 1000 plus 0.4 into 13.6. It is 600 plus whatever it is. So just this is your answer. Next question is problem 2. A stone weight 3 to 9.4 Newton in air. Find and 196.2 Newton in a water. Compute the volume of a stone and its specific gravity. Okay, so you have one stone, right? You are measuring inside water and in air. So this is your when you measure in air, weight is this, and when you measure in water, this, because in water density is more. So air density, if I take 1, and this is water density is 1000 kilogram meter per cube. So of course in water buoyancy force will act in upward direction, so weight will be less. So what is the difference of weight? So difference of weight is due to buoyancy, due to buoyancy, right? So what is the difference of weight? Difference in weight is equal to 3 to 9.4 minus 196.2. So this is the difference in a weight, and that difference is due to buoyancy, due to buoyancy force, right? Because in air we are taking reference. So here we are assuming no buoyancy, and then this there will be buoyancy in air, but in this problem our reference, because we always measure in a air, so basically the difference of weight is due to buoyancy force, or due to buoyancy force due to FB of water. So we can now write this is equal to uh, we have to volume of a stone you have to find, right? No? So volume B and rho W and G. So this is your buoyancy force. This is buoyancy force. So we can calculate here B. That may be in difference of density. No, sorry. What is the doubt? What is that? That may be in difference of density. No, due to, yeah. In fact, this difference is weight. Difference is weight due to the water buoyancy, right? No, you are measuring in water. You have air. You are measuring, right? This is your measuring device, and here you are seeing it is 329.6 Newton, and another measuring. This is inside the water. This is inside water, and you are 92.2, right? 196.2 Newton. So buoyancy force acts in this water, right? Right? You can take buoyancy. I mean, so difference of this weight, because this difference of this weight due to this buoyancy. Problem 3. A cylinder. So you have one problem. It's so basically a cylinder. This is your cylinder, right? This is your cylinder. This is your cylinder. This is your cylinder, right? So a cylinder is hanged in the bottom of a container in a vessel, and you have this height is 0.125 meter, and this height is 0.1 meter, right? And this is a you have one fluid, right? And this is you have here you have another fluid. So you have two fluids that I am writing here, fluid A. This is fluid A, and this is fluid B. So this blue color is your one fluid, and you have a black one is another fluid, and this cylinder is length is more here. Okay, so don't think it is completely submerged. So this cylinder is tied. So I write the problem for better understanding. A cylinder of mass 10 kg and cross-sectional area 0.1 meter square. So this area, cross-sectional area, is 0.1 meter square. Is tied down with a string in a vessel containing two liquids as shown in the figure. Okay, so calculate the tension in the string. Okay, so you have water density, 1000, and specific gravity of A is 0.8, and specific gravity of B is 1, means it is water. Okay, so solve this. I give you time 3 minutes because it is in a gate problem. So you have time 3 minutes. 3 minutes. Take your time, 3 minutes, and solve it. Okay, fine. So I think we have given a lot of time, right? Anybody got the answer? And the answer is your, I don't know what is the answer. Anyway, we will solve together. So if we draw free body diagram of this cylinder, so you have first weight, weight of the object, and then you have a tension in the string. This weight is your mg and tension in the string, and you have buoyancy force due to fluid A, buoyancy force due to fluid A, and you have buoyancy force due to fluid B, buoyancy force due to B. So we can write free body because this is in equilibrium. It is not moving in any direction. So free body diagram is this. So buoyancy force always acts in upward direction, and due to fluid A and due to fluid B, both will be added, and the weight acts in a downward direction, and the tension in the string will be in a downward direction, and like this, right? So we can now write the balancing force balancing equation, that is T plus mg is equal to force buoyancy force due to A plus buoyancy force due to B. So tension we can estimate buoyancy force due to A plus fluid A and buoyancy force due to fluid B minus mg. So you know mg is your 10 kg, 10 kg. So you can write here 100. Now our job is to estimate the buoyancy force due to A. Buoyancy force due to A. So A, how much buoyancy force? So how much volume of fluid A? How much volume of fluid A have been displaced? So this much volume of the fluid A have been displaced. So we can write now T is equal to area of cross section 0.1 into 0.1 into 0.1, 0.1. So 0.1, right? So with clarity we are going to write. So T is equal to 0.1 meter square area, and volume we are going to estimate. So this is your length. Then this is this much volume of A has been displaced, and then density, and then G plus. In case of B, you have area, cross section area will same, and how much height of the fluid B has been displaced by the body, so this is the, right? So this is the, so 0.125, 0.125, so 0.125. So, and this is your B, and then you have G, right? So you can, this is your volume of the fluid B, fluid B, fluid E. This is your fluid A. So that's why I have written here density of A. And so now you can estimate what is T tension. So that's all. Density of A is your 0. I mean 800, and B your water, that is your 1000, right? So you can calculate now. 0. So this is gone, right? So 8G plus, right? So this is also gone. 1.25, 12.5, right? So you write 12.5 into G. So your 9.25 G. So 92.5 Newton. Okay, I think I am wrong somewhere. Okay, anyway, just you solve this, you will get the answer. Just answer. Okay, so I think another problem. Everybody, I think getting this, or I think this clear to all. Clear to all. Everybody is getting this. सबको समझ में आ रहा है? What about Nikhil, Parveen, Sanket, Dinesh, Anupam, Satyam? I don't know what is his name. Is it clear to all? Now another problem. A balloon is filled with methane of density 0.75, this much allowed. So this is less than air density, right? So methane will float above the air, allowed to float in air with a human. Assume the density of air to be 1.25. This density is NTP, right? What is the volume of balloon? What is the volume of balloon which will lift a man, which will lift a woman or a man, weight 750 Newton, 75 kg. Okay, so basically this problem is to design a balloon, means you have to find the volume of the balloon so that so that so a balloon is filled with methane. So okay, let us make a balloon. So you have one balloon is filled with methane. So you have inside your methane, that is 0.75 kilogram meter cube density, and you have your air, everywhere air, and air density is 1.25 kilogram meter. So because of this density, this will try to move up. What is the volume? So 75 kg or 750 Newton, right? Weight. A balloon is filled with the methane of densities allowed to float in air with human. Assume the density of air to be this. What is the volume of balloon which will lift a man of weight this much? Okay, solve this. Let me check your concepts. So you have four options: 100 meter A, then you have a 60 meter Q, then C you have a 37.5 meter Q, then D you have a 150 meter Q. People, okay, so this is your W and this is your F. So F will be equal to W, and that is your mg, that is your 750 Newton. So this buoyant force must be equal to 750 Newton in a, I mean, just to lift the object, means buoyant force must be equal to or greater than 750 Newton. Right? So what is the amount of buoyant force? The buoyant force is equal to volume of, sorry, weight of weight of weight of fluid displaced. So which fluid is being displaced here? Which fluid is displaced here? Which fluid? You ignore the mass of this methane. Okay, otherwise you have to add here. So don't ignore this mass. It will be very small. So which weight of the fluid displaced? Which fluid is displaced? So it is air is displaced. Air is displaced. Surrounding is surrounding is surrounding medium is air. So here nothing to do with methane. This is the concept. So FB is equal to volume V into air into G is equal to 750. So this volume V is equal to 750 divided by 1.25 into 10, 9.8. So this is your answer. What is the answer? Air is displaced. Good, Anupam. So your answer is, what is the answer now? So you got the answer, volume D. So it is 150 meter cube. Anupam is 61. I don't know what is the answer here. You check. 750 divided by 125 into 9.81. So your answer is B, 61. So it is 60. That is B is your answer. Clear? Okay, fine, boys. So tomorrow we will discuss. Today we have started. So tomorrow again 10 o'clock there will be class, and we will be discussing about metacentric height, location of metacenter, and stability of the floating objects, stability of the submerged and floating objects. Okay, thank you. If you have any question, please ask. I have kept this class very small. Tomorrow 10 o'clock again we will be discussing.